Hello and welcome to A Piece of String, the show that brings together comedians and scientific minds to ask and answer the biggest of all questions ever. I'm Matthew Shribman, a chemist and biophysicist by training, and with me today are Josie Peters, an astrophysicist.
Hello there.
Sophie Ward, a biomedic and neuroscientist.
Hello.
And James Wells, an engineer.
Hello.
Each of us will ask a question to which one of us secretly knows the answer. Points will be allocated on a entirely arbitrary basis by our producer Sam Lee, and the winner will get this laptop that I am holding. God, it's
Good prize this week.
Yeah, I was just picking one of the things in my hand, of which I'm holding many, and this came out good this week. James, have you got a little question there, mate?
Yeah, I do. What do ants do for fun?
Have you seen the film Ants?
I have, a long time ago. It was
Well,
great.
there we go. I'm
Therein
not
lies
seeing
the
it.
answer.
What do they do? Aren't they in like an army?
Yeah, I think it's exactly right, yeah.
Similar to Bug's Life, though. Very similar films.
Is it better than Bug's Life? Because I only saw Bug's Life because I preferred the look of the bugs.
Well, Bug's Life had what was the little one in Bug's Life? I had a nightie. You know when you were young enough to wear a nightie?
Oh,
Like nighties are worn by young people and old people, and I was a young nightie. Dot, that's what she was called.
Oh, little Dot.
Oh, little Dot. Oh, cute.
Got a husky
Anyway,
voice like you.
yeah, I've shaped my whole life around wanting to be like Dot.
I was thinking, like, maybe sports, like, what do they do? Well, they would never be able to play football and stuff because they follow each other all the time.
Surely weightlifting.
So maybe it would be like a big Congo line. Is that what they're doing all the time?
Or could they pick each other up? They're good at carrying things, right? But what if they were like, all right, Bill, get on me back. Let's have a fun time. And
But I don't like you, Bill.
So maybe how many they can carry? Like it would be like, you know, those human towers you get. It's,
Spain.
There's it's the Sant Magi Fest, and it's like this big water festival. But they also get towers and stuff, human towers. So maybe ants do that.
I want to go back to the Congo line quickly because there's a thing psychologically when you watch a music video, the action does not necessarily have to be completely in time. Your brain is very good at kind of matching up the action to the sound that you're hearing, so that you think it matches. Has anyone actually ever tried putting a soundtrack, with a good beat to it, behind some ants just walking around? Because maybe they're already doing it. Maybe
They've got a tune in their head.
Yeah.
there must be somewhere in the depths of the internet a video of some ants with some music.
I feel like
there is.
craft work would work very well with them.
Oh, are they- what are
Something
they-
quite rigid and hard hitting. Don't know why. I think that'll work.
Have you guys heard about these ants that some of them will just be like a food storage thing in the nest, and they'll just like hang from the roof of the nest and drink huge amounts of glucose syrup, water stuff, and just turn themselves into a huge balloon that never moves, but they're alive. And then when food is low, the other ants will come and kind of eat out of this storage ant.
How do you think they feel about that?
I think they're chill.
Well, maybe
They can do nothing else.
They're
but
very
chill, I
much.
suppose.
They've got more of that community vibe, right? Because they don't think of themselves as the individual; they think of themselves as the colony. Isn't that right?
Yeah.
Do they regurgitate it
Yeah.
up for them, sort of like a penguin or something? Like
I think
a
so,
tiny
yeah.
penguin.
Oh, okay. I thought you meant that they might just all stick their mouths into the body and
That's
kill,
what I
thought,
sacrifice
yeah,
the
that's what I
ant.
imagined.
That's why I thought you were like, oh, does it enjoy that because it's being killed? So with the ants following each other, is it? Do they follow each other because of a scent or a hormone that they give off, or is it a sound? I can't remember what it is. Is there a way that they could like maybe prank the other ants and be like, oh, we've sent Roger over to the wrong ant's nest?
The way they do that is actually really cool with the smell. They have
It
like
is
a
smell,
like a
right.
democracy. So, for example, if there are scouts all going to find food, then they might all wander off in different directions, and as they go, they all tap their tails on the ground, leaving a kind of like dotted line of scent, so they can find their way back. But if they find some food that's like, whoa, this is great, then they'll hold their tail down and put a much thicker trail of scent on the ground, so that other ants can then follow it and be like, oh, food this way. And if they like it, then they'll also lay a good like trail of scent, such that the more ants that agree, oh, this is great food, the stronger the trail gets in terms of scent, and then eventually it becomes kind of a scent highway where all the ants are like, no brainer, great food this way.
Oh wow.
So they can vote essentially with their smell where the best food is.
I feel like with the food, they often bring back big lumps of leaf and stuff, don't they?
I wonder if it's like the ants, like they're all competitive, or maybe like the biggest leaf thing. It's like a Jacob's join. But then that'd be really annoying. Cause it's like, wait, you brought a leaf, I brought a leaf.
What's a Jacob?
No
Jacob's
one
join.
bought hummus.
Oh, excuse me, it's like a Jacob's join is when like everyone brings some food. So it's like if you were to have a party, I might bring a casserole, you might bring like meringue.
Oh, okay, yeah.
Oh yeah. Sorry, you seem like a meringue kind of guy.
Yeah, okay.
Yeah, flan.
I'm not.
You're a fan of the flan. Okay, fair.
Love the throw.
I was thinking competition. Oh no, I'm thinking of bees now. I'm thinking of bees. Oh, this is a
both
great
have
fact. I'm going to
queens,
say it
though.
anyway. Yeah, okay. I was just completely mixed up. But yeah, bees. When you got a queen bee that's damaged, then the worker bees will like feed royal jelly to like other little what are they called when they're
Babies.
babies. Yeah, them.
Baby bees.
Yeah. So feed royal jelly to them and try and grow a new queen ants. They might grow a couple, and the original queen will go around like trying to find them, and if it finds one, they'll like stab it to death through its like cocoon thing before it can get to full strength. But the worker ants will, worker bees, sorry, still getting confused. The worker bees will like try and keep the original queen away from where they're growing the new queen so that she can't find out. And then eventually when it gets to full strength, they unleash it and there's a battle.
It sounds quite medieval to me.
Yeah,
It is.
yeah.
Honestly, this was something I found quite hard to believe. But it is true, is that the bees actually have battle cries. So you can, if you are able to witness this event happening where like a new queen tries to take over from an old queen, then you can actually hear the bees like making these like sounds as they attack one another.
That's so amazing.
Although
Full Game of
high
Thrones.
frequency sound dissipates much quicker than low frequency sound.
Who's got an answer?
I've sort of put together a little answer. Where did I put it? Okay, so yeah, I've put together a little answer for what do ants do for fun. And the top line of my answer is nothing, full stop. Because I think to think that ants have fun is sort of to misunderstand what ants are, and this is what Josie was sort of getting us before. Because ants are, it's easy for us to think of the ants as individuals. And obviously, well, I know that was a story about bees, but they also act in a similar way to ants. But the story I just told about queen bees, it seems that the queen is acting as an individual, trying to protect itself. And that does still happen on a very small level. But on the most part, the best way to think of ants is that the whole colony is the living thing. So rather than trying to empathize with individual ants, we should be trying to empathize with the entire colony. So the question should maybe not be, what do ants do for fun, and more, what would a colony of ants do for fun? But at the same time, I think the answer might still be nothing. But someone did tell me once, though I haven't been able to find any proof of this one way or another, I did try really hard. Someone once told me that ants do recreational drugs. They told me about a fungus that some ants were growing that had been discovered that gave off this kind of chemical that made the ants somehow intoxicated, and they carried on doing it. But I've been unable to verify that claim, and I think that it's probably false.
Oh, I've heard of other animals doing that. I heard of a pony once eating fermented apples and getting drunk off the cider and falling about on the ground.
Yeah, there's a thing about reindeer. Reindeer eat fly agaric mushrooms, which makes them go to sleep at first. And then when they wake up, they don't have very good muscle control. So when it feels like they're doing small muscle movements with their brain, they're actually doing these huge, like bounding movements. And that's why they jump really high by mistake. And this is where a lot of people think is the myth of flying reindeer came from.
Wow,
It's them doing
they
recreational fly agarics.
jumped so high.
Sophie, what's your question today?
Where else in the universe do you have the greatest chance of living the longest?
Where else did you say?
Where else in the universe, other than here, do you have the greatest chance of living longest?
So we're looking for do they call them Goldilocks planets or something?
The Goldilocks zone. Yeah.
Zone, that's it.
It's
Goldilocks
just
zone.
right. It's the right distance from a star. It's not too hot.
Exoplanet.
It's not too cold. Just
Alright.
like the porridge.
Oh, I've just thought of
Nice.
a tangent. What if this is not to do with like habitability? What if it was like general relativity?
This is
time
what I was
slowing
thinking.
down?
Yeah. So if you're constantly accelerating, if you go on a journey away from the Earth and then back again, but you're constantly accelerating the whole time, then you will arrive having aged a lot less than everyone else, because traveling at a higher speed relative to an observer means that time travels slower for you.
Woohoo!
Wait, what? Can you explain that in any kind of
Space.
Yeah, it is.
Is that just one of those inexplicable things that is just
It's sort of
true?
yeah. It's a little bit difficult to explain. But let's do the relativity in terms of gravity because that's easier to get a grip on. But basically, if you're in a region where you're exposed to a lot of gravity, so on the surface of a big planet, then time will travel slower for you than if you are drifting around in space with not much gravity. So in fact, the center of the Earth. We think is about 2.5 years younger than the surface, just because of because of the relativity.
Because people have even measured this. They've used atomic clocks at, say, the bottom of a mountain and the top of a mountain, and the ones at the top of a mountain run actually slightly faster because there's less gravity acting on them. But a cool way to think about it is space and time are interlinked. They're one thing. So if you imagine space-time as a fabric like a tea towel, right, and everything's maybe flat and time is one of the other directions, I don't know. So by stretching that, you're not only stretching space, but you're also stretching time. That's the way that it gets me to help to think about why time would slow down, because you're not only stretching space, but you're also physically stretching time.
What's an atomic clock? Sorry.
Oh, sorry, that is just like a super, super, super precise clock.
It uses the frequency of a cesium atom, I
Yeah,
think.
cesium decaying.
Yeah. Yeah, nice.
So where am I going to live longest?
Well, no gravity, none. So no planets. You're not allowed on one of them.
Okay, just hanging around in space.
Yeah,
on my
do
lonesome.
not go near a black hole. That's totally going to ruin it.
Wait, you want gravity to slow?
Oh yeah, I've got
So
this
loads
totally
of
You got it the wrong way
I've got it
round.
totally wrong round.
Because-
Crap, sorry.
Because
Yeah.
if you go near a black hole or something else,
Oh, yeah,
your time slows down, but it feels
Of
normal
course,
to
yeah.
you.
Get straight into a black hole. Get
But I
straight
mean-
in there.
Don't get right in there, but yeah.
So I need to be cusping it on a black hole.
Cusping it, yeah.
Yeah, on the cusp of the black hole. Do I need to... What about my health? Does that not matter when gravity's involved? I guess it's so little
Guess
in
it-
comparison. I could eat what I like. That's quite nice.
What food would you go for? What would you take with you?
Well, you get those, like, astronaut ice creams. I'd like some of those. You get them from, like, the Science Museum and stuff. That seems appropriate.
Might take a Milky Way with me.
Maybe a galaxy.
Good.
Maybe a Mars.
Toad in the black hole.
So Sophie, do you want to come back, or do you just want to know that you've lived a lot longer than everyone else?
I know, my question was just about living long.
Yeah.
But, like, go on, if I wanted to come back, I mean, it would take a long time, wouldn't it? So wouldn't I die getting to the black hole? Like, where's our nearest black hole?
Center of the galaxy, yeah.
Depends how big you want your black hole.
Massive.
Yeah.
Oh, because we could get tiny
Because
instantaneous
there are
ones.
smaller ones that we know exist. There are these pairs of things called X-ray binaries, which binary just means pair. So you have like a star and a small black hole, like a few times the mass of the sun, that are paired together, and the black hole strips material off the star that it's friends with, and that stripping causes these really bright flashes in the X-ray, and that's why they're called X-ray binaries. But yes, so there are smaller ones, but if you want a really massive one, go to the middle of the galaxy.
Super massive one, yeah.
I often associate stripping with flashing.
Yeah. So the black hole at the center of the galaxy is about 27,000 light years away.
Okay, so I'd have to get there. I'd have to survive getting there.
Yeah, so at the speed of light, you could get there at 27,000 years, so that's
yeah,
fine.
and I can run that fast, so we should be all right.
Yeah. Wait,
actually-
also remember, if you're traveling that really, really close to the speed of light, I mean, obviously anything with mass, it's impossible for you to go at the speed of light. But theoretically, if you could go at the speed of light, then you would be traveling through space, but not traveling through time. So you could move from any point in space to any other point with zero time elapsing. And it may be that seconds or years or millions of years elapse on Earth whilst you're moving and you experience no time at all.
That makes sense, because if anyone else has watched Interstellar, where they go near that big planet with all the tidal waves on it that's meant to be more massive than the Earth, then they're like, oh, we've only been here an hour, and then they go back up to the spaceship and their friend's like, it's been 7 years.
Could we freeze someone?
Well, there's
hibernate them?
There's
Yeah.
companies that do freeze people, right? Like, there's these companies in America where they just have loads of people in these, like, metal tubes. It's proper futuristic, and it's, like, cryogenic freezing with the hope that they can be brought back in the future.
Well, that's actually been done. A
Yeah.
living
Yeah,
person
because
yeah,
people,
they're
people are
frozen.
frozen. They freeze them bit by bit.
Once they've died.
Once they've died, okay, that makes more
But also as well, if you haven't got as much money, then you can just get your head stored.
Yeah, like
So-
Futurama style.
Yeah, so there are all these creepy tubes full of full frozen people like Walt Disney and Michael Jackson. And then there are also tubes just full of people's heads who haven't got as much money. But still a lot of money, but not as much.
You could sign up to that if you really wanted to, James.
Yeah, right.
Yeah.
How much?
Why not? Saturday night?
Couple of quid.
Don't know. A little bit. So who looked up an answer? For me.
So I did look up one, but I initially went with the phrase that you initially went with, which was, what is habitable, what's in a Goldilocks zone? So I was having a look at which places had been seen as the most habitable recently. And there's this system of planets around a star called TRAPPIST-1, which is close-ish. It's like 3.7 million kilometers away.
Neighbours.
So close. Good neighbours. It has 7 planets. 6 of them have liquid or ice water. One of them might even have a global ocean. And people have been looking at the potential temperatures of planets there. D would be a balmy 15 degrees Celsius.
What's D?
So like there's TRAPPIST-1, B, C, D, E, F, and G.
What happened to A?
I don't know.
A gets used too much, that's fair enough.
Yeah. But planet D is a little bit too small. It's like a third of the mass of the Earth, so it might not be able to retain an atmosphere because the gravity wouldn't be strong enough. But maybe E, which has temperatures that are about the same as the Antarctic, so about doable if you've got a nice fleece, which is about 0.77 times the mass of the Earth. As there were some cool tweets knocking around recently because there was an exoplanet conference and people were spouting out cool things that if like, a planet is between half an Earth to 4 times the Earth, then they can outgas enough carbon dioxide to be habitable, regardless of whether or not something is being pulled tectonically by other planets or a star that's kind of heating up the center of it. So there's enough volcano stuff going on just from their size that you could have a dense enough atmosphere. So that's pretty cool.
Cool.
Yeah.
Oh, apparently the perfect conditions for an active young star are ones with laughing gas and the scent of almonds.
That sounds
For
like
a planet around
brilliant
an active
place.
young star.
I think, young star. Like,
Something to do with the molecules.
wow.
And quite an active young star, which sounds surprising to me.
What, an active young star? So someone like Saoirse Ronan.
Yeah. Spritz some almond spray on your love. There you go. So these are the most habitable planets that we know of so far. However, there are going to be new telescopes that are going to be going out there. There's going to be one called Plato going out into space in 2026, hopefully, from the European Space Agency. Also, the James Webb Space Telescope, hopefully next year in 2019. And also the European Extremely Large Telescope. Inventive names.
Great
kids.
name. I love that.
There's also a very
so
large
good.
telescope somewhere else. This one's even bigger.
Good.
This one is actually based from the ground, but will be active they expect to have their first light, as astronomers call it, in 2024. But basically, the point I'm trying to get around to is that these telescopes are going to be so much more sensitive and going to be able to see so much more than we can already see. That, fine, we think we've found some potentially habitable planets thus far, but in the future, we may be able to see so many rocky planets around sun-like stars elsewhere that we will have a wealth of planets to choose from. And it won't be trying to find a rocky planet around a sun-like star. It'll be which ones are we going to prioritize.
Sick.
Wow.
And now for the mystery midsection. Just before we started the show, I gave everyone the following question.
We've recently invented something called nanobots, which are made from platinum, wrapped in nickel, wrapped in graphene, and they're able to clean our oceans. But how do they work?
I then asked everyone to write down a fictional but reasonable sounding answer. I will now read out all of those answers with the real answer mixed in. Everyone will then get the chance to decide which answer they think is right. Here we go. They work by changing the plastics into methane on purpose. They act as sea police, stopping any other creatures from swearing, thus cleaning up the dirty language that is rife in the oceans. A chemical reaction propels them forwards, and pollutants stick to the beautiful graphene coat. A magnet is then used to pull them back to the ship, where the pollutants can be cleaned off. They work like tiny sheepdogs and herd the plastic into larger piles that can be scooped away. graphene attracts the pollutants, which stick within the honeycombs irreversibly. The nickel then degrades, catalyzed by the platinum, surrounding the dirty graphene in a permanent nickel oxide coating. What do you think, y'all?
Wait, what three things is it? Platinum, nickel, and graphite?
Graphene.
Even, yeah.
So graphene is like a single layer of graphite.
Super
Magic stuff.
thin. Yeah.
Discovered at the University of Manchester.
With sellotape. Oh, yes.
Boom, boom.
Okay, so the honeycomb thing, I kind of like it. I like it as a visual. Don't know about platinum's role as a catalyst, but all right. Having to think about that one. The magnet thing, well, nickel's a magnetic metal, isn't it? Or is it? It's cobalt, iron, and nickel. They're the magnetic metals, aren't they?
Yeah.
Yeah, they are.
What about the sea police?
Sea
Police, I think, is obviously the right answer, but that's why I'm walking through the other ones first. You know, like how on programs like Eggheads,
build
they
up.
say,
Yeah,
like,
yeah.
that's why that one's wrong, that's why that one's wrong. So, yeah, Sea Police, I think, because, you know, fish are known for their salty language. So, we need to get the Sea Police involved. So, I think that one makes sense. What do you guys think?
What about the tiny sheepdogs? I thought that was quite...
That makes me think that's yours, Josie.
I just noticed that it was the one that we forgot. And the plastic's going to methane. That was...
Yeah, but methane's bad for the environment, innit? So why would they do that on purpose?
Oh, true. Yeah, you don't want that.
We're trying to reduce the amount of methane.
Good point.
I'm just imagining a load of people on boats going, "Kumbai, kumbai."
Tiny whistle.
Good dog.
Wait, so two of them were kind of similar, right? So there was a chemical reaction that made the pollutant stick to the nanobot. And then there was another one where the graphene attracts the pollutant to the honeycomb.
So one of them, a chemical reaction propels them forwards, and the pollutants stick to the beautiful graphene coat. A magnet is then used to pull them back to the ship, where the pollutants are cleaned off. Or the other one, graphene attracts pollutants, which stick within the honeycombs irreversibly. The nickel then degrades, catalyzed by the platinum surrounding the graphene with the pollutants attached in a permanent nickel oxide coating.
See, I feel like these nanobots are called nanobots, right? So they're small, nano, small. And how many pollutants can you really get with one little nanobot? So much that the nickel then degrades. How much are you really going to catch?
Wait, and why does it have to be? Does it have to be a tiny bot? Why can't you get a big bot? Does it work better with nanobot? Is it something to do with surface area?
How many do we put out into the ocean?
Seems
Billions.
Like a colossal waste of time.
Go on then, let's have some answers. Let's clear it
Well,
up.
I think it's sheepdogs. I think there's no way that a nanobot could collect enough rubbish or plasticky stuff for it to be worthwhile. So I'm going to go sheepdogs.
Okay, Josie?
I reckon it's the honeycomb one because it had the most fancy words in.
Sophie?
You know what? I'm backing up. I'm going for the dirty language.
Dirty language.
Yeah. Because I think we all know it's the one that makes the most sense.
Okay, right. Well, I'm pretty sure Sophie came up with the dirty language one.
You got to back yourself, Matt.
You got to back yourself. You got to
in
back
your
your own
own
fictional answer. Who came up with sheepdogs? Was that Josie?
Yeah, it was me.
Josie's
Oh,
won. Josie's
it was
won.
really
Josie's
good.
won.
Yeah,
Yeah, and the reason why the honeycomb one has got so many fancy words in it is because I stuck a load of fancy words in to see what would happen. And that's not what happens either. So these things are super cool. What happens is you put like loads and loads and loads of them. I don't know what we're talking, like probably tens of thousands of them into the ocean. And then the reaction that happens with the nickel and the platinum like propels them forward. So they all move away from the ship, and then all the pollutants stick to the graphene, because the pollutants are just floating around in the ocean, but they like to stick to that kind of non-polar surface. And then you suck them all back with magnets, and then you hose them all down to clean off all the pollutants. And then you put them back into the ocean again.
So it's the magnet one.
Rinse, and repeat. My question is this. A form of ice has recently been discovered on Earth for the first time. If you were that ice, where would you have been made and how were you found?
Oh, wait. So this is a hypothetical ice. Or is this a real ice?
For realsies.
Whoa, what?
What?
Ice.
So the ice has been like hiding away.
Is it somewhere in the deep depths of a dark, deep cave?
When you said about how would it be formed, surely like the ice would be formed by water freezing, because that's what ice is.
Well, maybe, but I mean, there's so many different ways for things for it to freeze, right? So, like, you can supercool water below 0 degrees, and it can still be water, liquid water, even at normal pressure, if it doesn't have anything to kind of nucleate against to start forming ice. So you can get like a bottle, a very smooth bottle with which you've supercooled water, and then you can give it a little flick, bing, and it will suddenly turn to ice. And you can also do a similar thing where you can pour this water out onto the table and it will form an icicle as you're pouring it.
So when you said nucleate before, what does that mean?
So like a kind of there's a general rule in nature that things don't like forming tiny little droplets or tiny little collections of themselves. So in order for ice to form out of water, you need individual water molecules to bind to one another. But they don't like systems where there are only a few of them. So it helps if you've got some kind of rough surface, like a bit of sand or something, that they can all cling to then expand out from there.
It's like we like socialising, but we need a bar to do it in. The water molecules.
That's a good analogy, yeah.
Or a cafe, whatever you need.
So yeah, I was also thinking about allotropes. Do you know that word?
No.
So allotrope is like a different form of the same element. So like carbon, with carbon you can form graphite and you can form diamond, right?
Yes.
Different allotropes. And not really talking about water, but tin. Have you heard about alpha and beta tin?
No.
Please tell us.
Please tell us more.
Sounds really.
So yeah, please tell us. I don't mean to sound so sarcastic.
No, this is.
Are
this
there
is,
different ways to store our beans?
Yeah, like the Scott expedition down to the Antarctic, they had their fuel stored in these tin canisters. But unfortunately, if tin gets extremely cold, it can sometimes flip to the other allotrope where it's like really dusty and powdery.
Oh really?
Yeah, and so the fuel canisters would just like turn to powder at the bottom, and all the fuel would disappear, and they'd leave the canisters at checkpoints to collect on their way back from the furthest into the Antarctic they'd been, and that was one of the reasons why they think they all died, is because at many camps they came back to, they found all the fuel had disappeared out of the canisters.
Oh, would you be so gutted? Like maybe we should just take every material to every really extreme place and just see what happens to it, just so we know. Need to make sure things get tested thoroughly.
It's still causing problems, like American soldiers in Afghanistan. There's stories about the computers when they're trying to call airstrikes not working because the solder in the computers got so cold, and it's still made of tin, that it's turned to this like dusty allotrope. And there's one other one which I think is a bit of a rumor. We're not I think this is a bit disputed, but this idea that Napoleon's soldiers had tin buttons on their coats, and when they went in to fight against the Russians, a lot of them turned to dust, and so the coats couldn't hold themselves together, and that was why a lot of people froze.
We need to just stop using tin.
What
Tin
else?
for the bin, you know?
Bin the tin, a new campaign by the government.
James, what do you think, mate? Have you? I mean, you're being very quiet, so I think
Yeah,
you've probably researched an
suspiciously
answer.
nice.
Suspiciously quiet.
Shall I flop some answers out?
Yeah,
Right,
go on, mate.
so this was an interesting one. So a guy called Oliver Chauner of the University of Nevada in Las Vegas. I like the idea of a university in Las Vegas. But anyway, he discovered inside a diamond, a form of ice that had never been found on Earth before, which is ice 7. Now, it's been made in labs before because...
Whoa.
Yeah, go on.
Sorry. Ice 7?
7.
What are the 6 other
I was going to
ices?
say it's like Fast
Well.
and Furious, isn't it? Like Ice 7.
There are 16 different crystalline forms of ice possible.
Wait, so is that the structure that makes them different?
Exactly. So you can imagine if you had liquid water under very, very high pressure, you could create ice at a very high temperature because all the molecules are being squidged together such that they form a solid. So you can do this in loads of different ways. You can get really, really high pressure and then raise the temperature slowly, or cool the temperature slowly, whichever way you're doing it, and you'll form different forms of ice. So there's 16 of these different types of things. Essentially, what this guy found inside occlusions in a diamond was what had been captured when the diamond was formed. So deep down in the earth, about 600 kilometers, we've got pressures of, it could be up to sort of 3, 4, 5 gigapascals, which the Marianas Trench is about 1,000 atmospheres. And 3 gigapascals would be 30,000 atmospheres. So we're talking 30 times, 40 times more pressure than the bottom of the deepest ocean.
Whoa.
So really, really good stuff. So basically, these diamonds form, and they've got an incredible tensile strength. So they're able to withstand the pressure at that time when they rise to the surface. So what's happened is this diamond inside it has an incredible pressure, which is keeping the ice in its form. Amazing. So what else have we got? This basically proves that there's a load of water in the Earth's mantle.
Yeah.
What?
And this is the first example that they found of this to be true. They thought it was true, but they never found an example of it until this year.
The mantle being the layer of the earth beneath the crust.
Yes,
Yeah.
absolutely. Yep. And it goes
Okay.
real deep.
So we think that there's 3 times more water beneath the surface than there is on the surface of the Earth, right?
That order of magnitude, yeah.
As a checky thing, is tensile strength, is that like if you tried to stretch something, is that what like that means?
Exactly.
Okay.
Yep. So you have tensile strength and you have compressive strength.
Because the water's pushing from the inside.
Exactly.
So you need that strength to keep
So
it
you
in.
need
yeah.
tensile strength. Sort of like a balloon if you're blowing up a balloon.
That's amazing.
Okay, so what they found examples of this ice at pressures as high as 24 gigapascals. So I thought, that doesn't really mean a lot to a lot of people at all. So let's put that in context. So if you imagine your body was a meter squared, it would roughly be equivalent to 48 Titanics weighing down on you, or 7 Empire State Buildings. So we're talking incredible pressure in this diamond. Now diamonds can, if they're structured perfectly, can take up to 240 gigapascals. So we're talking 70 Empire State Buildings on you. If their crystal is perfect, but they're often imperfect, so poor little guys.
Cannot wait for Water 8 to be released. It's going to be big.
Yeah, I believe it stars The Rock. That was by accident. He's just in lots of sequels.
And what did amuse me was this guy wasn't even looking for this sort of thing. He was looking for carbon dioxide, and they're still looking for carbon dioxide in diamonds. So the poor bloke isn't even satisfied with it.
That's often where you find the most interesting things, though, isn't it, when you're looking for something else?
Very true.
Nice
Very
little
true.
philosophical thing to put on a postcard.
Josie, have you got a question for us?
Are happy tears different to sad tears?
Have you brought in any samples for us to taste?
Hold on.
Josie, you're ugly, mate.
Oh, no.
Give me
Here's
that.
the sad one.
Josie, you're not that
delicious.
ugly, mate.
Oh, Sophie, I knew you understood me. Oh.
Also delicious.
So they taste
Those
the
on
same,
your
right?
chips.
Yeah.
Yeah, they both taste real good.
Why do people cry when they're happy? I'm not sure I've ever cried tears of happiness, I'll be honest.
Really?
Oh, I think really never.
Oh.
Not
I
even
don't
if
think so.
James!
I know.
What? Really?
No, I don't think so.
I
Come
think
on,
I have
mate.
once.
Well, I think like happy crying, it's just like intense like emotion, isn't it? And I think that people cry for happiness for different reasons. Like I think it's often when there's been a release of stress. Like if you see someone you haven't seen for ages, it's actually kind of a manifestation of all that stress you've been feeling before getting released, and because you're releasing it in a happy zone rather than a sad zone, I think maybe that's what it is. What about crying laughing though? Like have you ever cried laughing?
No.
You will do when you listen back to the
I separate those
podcast.
very much. I've just remembered, I've cried from happiness loads of times. Weddings. I always cry at weddings. Every single wedding I go to,
exactly.
I cry.
Do
Yeah, and
you?
they're guaranteed, yeah. It's incredible.
That's the thing. It's less.
I've
It's
realised
less
I do.
happiness. It's more like kind of something really beautiful.
Yeah, exactly.
Something, and it's like that kind of bittersweet kind of. Yeah, because I
Yeah,
cry
yeah,
from this
yeah.
all the time, mate. Almost
All the time?
All the time. Every like you get a beautiful new piece of music.
You have
Sam
been married
sent-
quite a few times. Then.
But does music make you cry with happiness?
Yeah, Sam sent me this track like a few days ago. I was weeping at that on the tube. It's beautiful.
So is that
Weeping on the tube.
Is that
Sounds
a happiness, or is that like a kind of it strikes an emotional chord with you, and that emotional chord happened to be happiness, I guess?
Well, yeah, it's not sadness. It's just something really beautiful, and you're just like just emotionally very powerful. I guess that's more towards the happy tears end of the spectrum.
Yeah, are happy tears and sad tears do they come from the same place? Are they made the same way? Because you can feel like physical pain, right? Like if you're emotionally distressed, if you like really, really miss someone or really sad about something, you can feel the pain inside you and then the tears come.
There are thoughts, aren't there, that not all of our emotions and ability to respond to things is in our brain.
Ooh, I like
But actually,
that.
we have the ability to store memories in our other body parts.
What?
Mate, have you heard about this worm? What's that worm called?
Do you have a
Earthworm
surname?
Jim. He's such a groovy guy. Earthworm Jim. He
Okay.
rockets through the sky.
Or is
Oh,
it
I've got it, got it.
Pauline?
Planaria. It's like a flatworm thing. And that can have like basic memories. You can teach it certain things about like certain preferences for food and stuff. And then you can literally cut the whole thing into individual cells. And every single one of those cells has the potential to regrow into a full worm again, which will have the same memories of the things that you taught the original large worm, except for the IDOT cells, which they're already too differentiated.
That's mind blowing.
I was thinking of memories. I don't know if we're pointing at each other with the same thing, James, but I've heard of memories that have been passed through generations. So there'll be a grandmother mouse will be shown around a maze and she will learn how to go around the maze. The daughter mouse is then put in a box, never sees the maze. She then has another daughter or son or whatever. And the generation after, so the granddaughter of the grandmother mouse can go through the maze already because it has the memory passed down from the grandmother mouse.
Well, I guess you ought to think of things that reminds me of things like instincts, right? Like, where do people get instincts from? They must get passed down, like, you know, recognizing that certain colours of fruit are ones that we wouldn't want to eat because they don't look as ripe and they might be bitter or whatever. Like, or the very fact that bitterness, we don't like bitterness because it reminds us of poisonous or bad things that we shouldn't eat.
A lot of people have quite a strong aversion to purple, and we think there's a lot of scientists who think that this is to do with the memory of very powerful people wearing purple, the people who were in charge of discipline, because obviously purple was such an expensive dye color to make that if you saw someone who was wearing purple, then you would instantly be fearful because they're the kind of people who are going to hand down justice and so on. Or injustice, as it may be. But yeah, in terms of the theory of passing down memories, there are two things. So there's epigenetics, which we now understand is something that your genome can adapt during your lifetime, and then you can pass down this epigenome, which is the layer on top of your genome which switches some bits on and switches some bits off. You can pass that down to your kids, and so to that extent there is a way of passing down some information. And also, sorry, I've been talking for ages. We think there's a lot of memory embedded in proteins in a way that we don't fully understand yet. And this might explain memories being able to be passed through single cells, because we know that we have this thing called the ARC protein that's able to communicate the shapes of different proteins between cells, and there's no other, and that exists in our brain and help. And if you deactivate the ARC protein, then we can't store memories anywhere near as easily.
Wait, what? Wait, there's a protein that stores your...
There's a protein that mediates, that it communicates the shape of other proteins between different cells in your brain. And if you switch it off, then you can't store memories easily. So there's something, but it's we don't understand much about that yet. But the point is that there's some way to do with the shape of proteins that you can store memories inside cells that we're still learning about.
Oh. And maybe your happy tears.
Yeah, has anyone researched an answer to this one?
Yes, I have. So, happy tears, sad tears, right? We've actually got 3 main different types of tears. So our tears can be split into 3 categories. We've got basal tears. Those are the tears that always make your eyes wet. They keep your eyes lubricated and keep them nice and moist and squishy. Then we've got reflex tears. So those are tears that come out when your eye gets irritated or when you're cutting an onion. That's what reflex tears are. Then you got psychic tears. Now these are basically emotional tears. So happy and sad tears are both put into the realm of psychic tears, emotional tears. And actually, I was trying to find like any evidence because I thought, well, their chemical composition is probably very different, right? And yes, like emotional tears have a different chemical composition to your basal and your reflex tears. They contain more hormones related to stress. And for example, they're thought to contain more of something called leucine and enkephalin, which is like a natural painkiller that our body releases under stress.
So when you're crying, are you literally crying out the stress? Because you said that the tears contain cortisol. So that's why you feel better. You often feel a lot calmer. Like you have a good cry and you're like, oh, I don't feel as stressed because you're literally releasing the stress from your body.
Would that work? Are you getting rid of enough stress?
Well, it's actually the name of the hormone is the adrenocorticotropic hormone. So that's like related to like stress. I don't know if it's cortisol exactly, but perhaps, yeah, like you've got such an... If you hadn't let go of them, the high levels of this hormone could maybe get toxic in your body, and then it starts, it's a good release.
Gosh, and so you sort of overflow with tears as such to kind of release that amount of stress. That's so cool.
Although there was a study that found that when we say a good cry makes us feel better, that might be because of the emotional support you receive because of crying. But just to get into the nitty-gritty of it, there's actually something called pathological laughter and crying. Now, pathological just means like sort of disease-related. And this is when people have had damage to a certain brain area, and it leads to uncontrollable outbursts of both laughing and crying. So it's thought that that these emotional areas are actually well connected. So actually, if you're crying and laughing, like they actually might be more connected than we think. In fact, it's thought that like moments of intense emotional arousal are connected to a part of your brain called the lacrimal nucleus, which also stimulates tear production. So there we go. It's actually that happy and sad tears might not be that different after all.
And we have arrived at the end. Points have been allocated by Sam Lee according to a system that none of us understands. Sam, what's the verdict?
Well, before any of you even started talking this week, the die was cast, and there is a pun there, as this week's scores have been awarded based on the colour of your shirts and the frequencies of light that the dies used for each of them reflects. A little bit complicated, but bear with me. So with 685 nanometers, Matthew is this week's winner for this lovely orange chemise that you're wearing.
Yeah, but it looks horrible though.
There's a pretty decent amount of yellow on the shirt that Josie's wearing today, putting her in second place with 569 nanometers. James, a noble third place with 530 nanometers for your green. What kind of material are we calling this?
It's sort of smock-esque.
Okay. And Sophie, unfortunately, the T-shirt you're wearing today is black, so
like
reflects very little light at all. So you're this week's loser, unfortunately.
That's all right. I'm bright enough as it is.
For now, thanks to Josie Peters,
Au revoir.
Sophie Ward,
Thank you.
James Wells,
Bye.
Matthew Shribman, that's me, and our producer Sam Lee, and to Unbound for hosting us. You can follow us on social media by searching A Piece of String or String Podcast.
If you'd like to follow me personally, you can find me at Josie A. Peters on both Twitter and YouTube.
And if you want to see what I'm up to, I'm also on Twitter and YouTube as Soph's Notes.
And you can follow me on social media by searching Science in the Bath or Matthew Shribman.
If you have a quirky question of your own that you'd like a scientific answer for, then please reach out to us on any of our social media channels.
Thanks for listening. We'll be back again in a fortnight, and as usual, let's never speak of any of this ever again.